advocated for a more comprehensive, competitive semiconductor and photonics and manufacturing industry. Carlos has a BBA in finance and an MBA in leadership and change management from United Business. He lives with his spouse and 3 children in Belgium. Thank you, Carlos, for being with us. Okay, it's a pity you could not come, but anyways, let's hear Carlos.
Thank you very much for the introduction, and it's a pleasure to be with you virtually. So that's again the luck that we have, that technology allows us to be present without being physically there. I'm also hoping that it also will be an interactive session, so feel free to raise. I cannot see you, but I'm sure that if you raise the hand, somebody will give you the microphone, and I'm happy to take questions in the presentation or afterwards. You don't have to have questions or comments to the presentation, but I'm hoping that in the topic of entrepreneurship, we're dealing with people who are curious and who challenge ideas, so I very much welcome that. So I remember going to Brazil. It was 2018. I've been there. I liked it very much. I've been there. It was great. I had a great souvenirs. I visited the synchrotron, and it stays as one of my fantastic memories because many people can see a synchrotron, but not so many people can see a synchrotron in construction. So it was an absolutely fantastic opportunity to be able to be there. And I also took the opportunity to visit some companies, Julio Oliveira at the time. I visited some research organizations, some startups, also the technology development centers. So I very much enjoyed my time when I was there. And also one of the things that I love in life is eating. And so that's how I discovered the churrascaria, which is actually quite exceptional. So I look forward to my next trip to Brazil. On these topics of presentations, I like sharing some of my ideas. This is from the summer. I went to the Lahore Women College, where they focus on photonics, and made a similar presentation. I like to connect ideas and people from around the world. I had 13 intercontinental trips this year, mainly to Asia. So I really believe at connecting the world. So although I live physically in Belgium, I'm glad that I can make the presentation to you in Brazil. As you mentioned, EPIC is an industry association, a not-for-profit industry association. We are membership funded, and I spend most of my time working with companies. So although I have never worked at a company, I have never created a company, I'm hearing company stories for 25 years. 11 years at EPIC, and as you mentioned before, 16 years at the Semiconductor Association. So I feel like I'm a priester, who hears a lot of stories. I haven't done things myself, but I hear that, and my presentation is based a little bit on that. My presentation is kind of loose. I'm just throwing ideas, and I think it's just some food for thought. And as I said, please challenge the ideas, confirm them, or ask questions. I'd be very happy to do that. So I'm hoping my presentation will not be too long to allow the time for that. As you mentioned, we have 830 companies. These are usually small companies who make like optics and fibers and lasers. Some of them assemble them, have a product, and we are a European organization. We're not government funded, we're not political, but somebody has to take care of Europe. And so that's how the association was created 20 years ago. Photonics, anything, we go from the whole range of photonics, anything that is capturing the light, creating the light, modifying the light. I'm not going to go into detail of all of these applications. I just mentioned them here over at this talk to remind any of you who have studied photonics that you have an amazing future ahead of you. Why? Because it's another key enabling technology. It's hard to find anything that is not related to photonics. So if you already have this technical background, you will in any case have a fantastic, bright future. Communication, again, I will not go into details, but this is how I kind of explain all the applications of the photonics. So the communication part, all the entertainment part of photonics, all the energy. Of course, people always think of solar panels, but even if you just take the windmills, you have the fibers to monitor the strength, the blade as it's bending. So using that fiber, that would be part, so in renewable energy on the blade of the windmills, or if you just take the LiDAR to scan the speed of the wind, these are other applications of energy. Transportations, all the LiDAR cars, of course, laser lighting, a lot is happening in transportation. Health, cancer analysis, cameras for blind people to see, a huge amount of photonics in health. in industrial manufacturing, for cutting, for welding, for inspecting, lots of activities there. Security, defense, rescue, lots of things there. Agriculture for the crops, precision agriculture, indoors farming, arts, being able to see what is behind the painting, all of that. So no matter, let me just go back to that slide that summarizes here. No matter what you like to do, you will always find an application of photonics. And as I'm 48 years old, and when I was studying, we were being asked the question is, what do you want to work later on? You know, like an accountant, a sales or marketing person or something like that. But I think that today you can turn the question around and you can ask yourselves, what problems do you want to tackle? And you can take anything. You can take food poverty, energy, equality. If you take the United Nations sustainability goals, and I think there are like 40 or 50 of these sustainability goals, for all of them, you will find some connection with photonics, which is why the United Nations, UNESCO, agreed to make the International Year of Light, because we address all of these sustainability goals. So no matter what you like to solve, and I think that is the nice question to ask yourself, what problems you want to solve and how do you find the connection with that with photonics? So photonics is an amazing technology. I'm a bit jealous of you who have studied that because you actually understand how these things work. So the numbers here, I picked up a couple of old slides because it's not about the numbers, but it's just to remind that, you know, it is a sector. You know, if you compare this to semiconductors, the semiconductor electronics industry is much larger. That's a fact, you know, in some fields, but it's a significant industry. It is billions of euros. In Europe, it's 500,000 people that work in that field, and it is considered a key enabling pervasive technology. I add the word pervasive because you really find it in everywhere. When I go to schools and I challenge the children, I say, name me anything, the jeans, the light, glass, I don't know, flowers, name me anything, the apple that you're eating, and we will find a connection with photonics. Again, it's not about the numbers, but it's how you can look at photonics. You know, you can split it into many different ways on the action that they do, on the function that they do, on the application that you want to look at it. But it's just pervasive. So I actually enjoy photonics very much. You can compare photonics to other key enabling technologies: manufacturing, materials, biotechnology, nanotechnology, software. I mean, these are all these. You know, in the end, you can talk about semiconductors, about photonics. I just put it all together. It's just high tech. You will not find electronics without photonics and not photonics without electronics. So it's just all these high technologies. And I think that it's amazing what we are seeing being developed regularly. On a regular basis, you see new applications being put on the market. And what I find very exciting is to see them being put on the market in high volume. So we're going away from the niche, which is just a technology, something that could do something, into something which is not only being used in big laboratories or like a synchrotron, but it is really put into the hand of the people, most of this example being a mobile phone. In Europe, but I'm sure that you'll have the same in other parts of the world, even if the numbers are different, is how things are scattered. You know, photonics is everywhere. And I would love to see a map of South America or Colombia, where do you have research organizations, universities, some companies that make photonics, that use photonics, which are integrators of photonics, but it tends to be pretty much scattered. If you look in Europe, you will find it in many, many countries. We have members in 33 countries. So photonics is not something which is just in a couple of countries. Germany and France are the most active. Germany #1, France, UK, and then you'll have Netherlands and Switzerland. But you do find photonics a bit everywhere. So it benefits a lot of companies. In Europe, 5,000 companies that supply photonics and use and integrate photonics. So it's a very interesting ecosystem, but which is mainly composed of small companies. 86% of the companies in photonics have less than 100 employees. So when I'm asked the difference between electronics and photonics, I would say that technology-wise, it's pretty much the same. If you take a phone, you could say that the display is emitting light. It's electronics and photonics. The camera is capturing the light. The optics are modifying the light. The pixels in the front are recognizing your face. You can say it's electronics or photonics. And the answer will probably depend on what you have studied, on what is your background. But I think the major difference is that the companies involved in photonics They tend to be smaller, younger, and very innovative. This is the picture that I like to show for innovation. It says IBM. I think this is just a hard disk or something, and it's probably 60 years old. And I'm sure that whatever that is, some memory chip or something like that, probably it fits into my pocket today, and it's 100 times more powerful. So no matter what ideas you're having today, I keep saying the iPhone of photonics does not yet exist. It's getting smaller. You can look at many of these applications, and as it gets smaller, cheaper, the performance is very often there, but the problem is that it has to be cheaper and smaller, and to be able to integrate into systems. But we are seeing on a regular basis photonics spreading out, and that is creating opportunities, business opportunities. So as the technology matures, not in performance necessarily, but as in size and price, it opens a lot of opportunities for business. So that's the picture I use for innovation. And the picture I use to show how it can change people's life. This is the picture when the Pope was introduced in 2005, and the Pope in 2013, and you can see everybody holding the camera. So the photonics technologies change the way that we live, whether it is for the internet, but making it available worldwide. I think that's it. A third of the people don't have access to the internet, but to make it available on a global basis, through free space, satellite communication, or some other ways. But photonics changes lives. So going on entrepreneurship in photonics, and again, if there are some questions, feel free to interrupt, but otherwise I'll finish soon so that you can then ask the questions. So I just had a couple of thoughts as I was hearing the first presentation, and wrote here tips to become entrepreneurs. I was reminded here really the idea is to be, if you want to become an entrepreneur, I would say learn from those who did this before you. And by the way, at the end, feel free to add some other ideas based on your experience or what you think, or challenge any of those. But many people have done this before. What relevant learnings can we have? I think last year we published 50 CEO interviews. We published them on Novuslide. So if you just Google a big interview on site .novuslide.com. If you don't know, when you put site double points, it's like he's only going to search into the novuslide.com, which is a news website. And so it's kind of a search engine just with novuslide.com. But you will be able to see a lot of these interviews. They're just 1 or 2 pages. Get inspired by that. We always ask the question, what would you have done differently? We can learn from the others. And I think we have to find, your starting point will be to find something unique that you have, either a technology, a market, a concept. What is that uniqueness that you have? Because photonics competes on a global level. So at a global level, what is it that you have which is unique? Understand who are the customers, understand the ecosystems. What is it that you have? Who would be integrating that? Who would be using that? Who are these? And I'm a bit shocked, in fact, about what I experience is a huge divide between academic research and the industrial world. But if you want to commercialize something, we're talking business, you need to understand what is that, not the academic ecosystem, but the industrial ecosystem. So who are the customers and the customers of your customers? And then discuss the idea with them. Try to get feedback on what your idea is and listen. I think number one is to be able to listen and to get that feedback, and not to be in love with our technology, and to be honest with ourselves and the feedback that we're receiving. Our previous speaker also mentioned that to building a network, I very much believe into that. Whatever you're going to need to further the technology, to industrialize it, to manufacture it, you need people, you need companies. So I'm a strong believer on having a strong network. Talk to other entrepreneurs, talk to customers. And also, it's not just about the technology. It's not because you have the best technology that is going to work out. Please think sales, think marketing, think business. And many of you who will maybe create a photonics entrepreneurship, a photonics company, maybe your starting point, actually, I think for most of you, the starting point is not like, I want to become rich. And you're doing that because you're passionate, because you like what you do. And that's great. You should do what you like. But there is nothing wrong with making money. And you will need the money to be able to invest more into the research and development, to be able to further advance technology. So it's fine to make money, sincerely. So this is the slide I like for entrepreneurship. That's the plan that we have, and that's the reality. I think there are very, very few stories, maybe 10%, which is like, wow, we had this idea and it just worked out. I think 90% of the other ones, that's what you're going to be facing. And that's fine. That's why being the CEO, Chief Executive Officer, or Chief Everything Officer, because you have to do so many things in the beginning of the startup. But that's what it is. It's resilience. It's never giving up. You continue going forward. That is what is going to be required. I put here a couple of cartoons that I like to share, which I think it's not so much on. It's just some philosophical quotes, whatever you want to call it. But I'll just throw it in here for your thinking. So life is short. Work somewhere awesome. So either you work somewhere awesome or you create your own environment. But just go for it, especially if you're on the younger side. I've got 3 children who are 23 and twins of 20 years old. I just say, enjoy, experience, learn. Just go ahead for that. And again, if you're going to be an entrepreneur, Chief Everything Officer, CEO, just you have to do whatever you have to do. And this, it's not my job. Well, that's in industry. Well, you can do better than that. A part of the hard skills, also the soft skills. This customer service. It's an attitude and not a department. I think you can apply this for many things. But have that mindset of really being helpful. Be the one that people want to work with. That you just excel. You exceed expectations. Try to become that person. Procrastination. Yes, the customers, they don't wait. It takes a lot of discipline, but try to do things. Most of the time, we know what we have to do. It's in the execution part. And just an idea with no execution, it doesn't get much results. So do the things. And if you have this thing that you want to go fast and success, well, I think most of the time it's just not like, oh, I've got that idea and it's just gonna work out. It happens, but most of the time it's hard work and perseverance. You maybe also have the feeling like, well, who am I in this world? I'm just a student, or I'm in a place. Who am I in this whole world to make a difference? Well, if you think that you're too small to make a difference, think of a mosquito in the room. It's being noticed, so you can do it. And then to listen to the feedback. And it's not because you listen that you must agree. It's not because you listen that you have to implement what others are saying, but just consider that. So the biggest communication problem is that we do not listen to understand, is that we listen to reply. Take opportunities. When you see the opportunity, take it. When they see you knock on the doors, if it doesn't open, look for another door. And if there is no door, create your own door. But take the opportunities. And you sometimes see people who have had opportunities in life, and they didn't take it. And maybe afterwards will complain or say like, well, others are so lucky. But take the opportunities when they are there. And if you don't know how to do it, then just say yes and learn how to do it. So they say, jump off the cliff and build the airplane while you're falling down. And, sometimes you win, sometimes you learn, it doesn't work out. But if it doesn't work out, get the learning out of that. And you fail 1 time, you fail 2 times, you fail 3 times. No, in fact, the more you fail, the more you learn. And it always prepares you for the next step and the next step and the next step. Dream big, go for it. Have these big ambitions. And finally, never give up. So these were just some thoughts that I had, and I'd be happy to have. I'm going to stop the sharing so I can see you back. And please, I'm happy to have any questions or feedback from you. Thank you. Well, I cannot see or hear you, but I'm sure you'll turn the camera back on. No, I can see you now. It's nice to see you because the camera was put on the other way around, so it's nice to have a view on the. So hello, everybody. I can see you. You're waving. Nice.
I here have a microphone. So I'm Felipe, I'm a postdoc here at Unicamp. And I'd like you to explain a little bit further what you said about not falling in love with your tech, being honest with yourself. I find that very interesting, but I'm not sure if I get what you mean.
So a lot of the entrepreneurs, so Epic has all these members, and most of these CEOs probably have a PhD. So they probably did a PhD, developed something, and then decided to make a company out of that. And it's their, they are in love with their technology. It's just like, it just means what I mean. They're in love with their technology. That's great, it's perfect, and they will not hear the feedback of the market. And the market may be telling you, we don't need it, we don't like it, it should be different, we have other solutions, but they just keep they just keep focused on that. And so the one hand, it's a bit contradictory, because you say, like, don't listen to others, keep going, keep your way. And at the other side, it's like, well, you have to get the feedback of the market. So I would probably, if I had to refocus, that is like, listen to the relevant feedback a bit more. Not everybody's opinion is equal weight, but I think the one from the customers and the customers of the customers, for sure, you need to listen to that. And if it turns out that this is not what the market needs or wants, or that there is another way of doing it, well, validate it a couple of times, but maybe that's it. Maybe that's not the thing to do. So so the stubbornness, sometimes it works, but I think you should listen and consider that. So it's just like, I don't know if it's clear, or but that's really what I meant to say.
Okay. It's Mark.
Hello, thanks very much for your inspiring talk. And I'm Brazilian, but I did my PhD in Europe, and I'm quite sure that the engineers and physicists from here are as good as the other ones in Europe. And I have two questions. The first one is the following. So I've been working with 5G in the last 10 years, and 5G is now coming to the market worldwide. And I'd like to ask you, what's the key application of photonics in the 5G and 6G scenario? And the second one is, what's your opinion about power over fiber?
Did you say, what's the last point, to partner or not to partner?
Sorry?
What was the last thing that you said? What the last point was, if we should partner or not partner? Is that what you said?
Power over fiber. POF.
Fiber. So I'm not a technology expert, but the point I would make here is that if you're talking about 5G, where in the value chain do you want to position yourself? So do you want to make routers and become like a Huawei or a Nokia, something like that? Or do you want to have a specific technology that will be incorporated by one of these companies? Look at things on a global basis. And while I used to say that technology has no border, investment has no border, it's a picture that I have said for 20 years. Unfortunately, this has changed. Well, not unfortunately, but it has changed. The US has really put a border on technology and on the investments and transfers. But look, as a businessman, and also in the research side, look at what other countries, maybe China or some other parts, what they are really doing on this technology. So first, always look at on a global basis, because in the end, companies will, that's the competition, or the opportunity is on a global basis. Two, where do you want to be yourself into the value chain? And what is it that you realistically can do? Can you become a Cisco? And I'm not saying that you cannot become a Cisco, but the companies that were created like Cisco, whatever it was, 20, 30, 40 years ago, maybe today's environment, it's harder to create such a multinational. I think that what we have less the opportunity today is to grow organically. You just grow by yourself and you have the time. I think you will either be acquired, and you have many companies that are being acquired. 100 photonics companies are being bought every single year on a worldwide basis. So you will be acquired, or you will have to have a huge amount of investment from outside to be able to really scale up and grow. So where in the value chain do you want to position yourself? What is it that you have? And the one on the power over fiber, I don't know enough to comment about that. But so my two comments would be that. Where do you position yourself in the global value chain, in the manufacturing value chain, and on a global basis?
Okay, thanks a lot.
And a question, you can ask in Portuguese if you want.
And thank you for asking questions. I enjoyed the interaction.
Well, I have a question, in terms of the industry, the industry, small companies here, and medium companies, or even the university research, like applied research, how can we somehow partner with Epic somehow, like exchange experiences, how this can be done in terms of even doing business, let's say.
I see, as I mentioned before, this huge divide between academia and industry. And and I hope to be wrong, but if you're working on something specific, all of you, I guess you work on some research, do you know who are the potential, what are the applications of this technology, and who are the companies that would be able to integrate this? And if you don't know the answer to that, that shows my point about this huge divide, which is, I'm not saying it's right or wrong. I'm just saying that if you want to work with industry, you should know industry. You should know who these companies are. You should know what their needs are. Do they want something which is more performant, or do they want something which is faster, or just smaller, or lighter, or cheaper? And I encourage you, if you want to engage more with industry, I think that you have to spend more time with companies. So for instance, if you go to Photonics West, are you going to spend most of your time on the academic scientific talks, or are you going to spend time on the show floor talking to companies? So yeah, I think there is an opportunity to bring together academia and industry.
Oh, no, sorry, the question was more like how can the ecosystem here of companies, even perhaps some universities, can work together that way, trying to exchange experiences and trying to learn the place in market that they could benefit by working together that way. I'm just asking, how can Brazil and Epic work since we are not in Europe? That's the question.
Well, Epic organizes most of its events in Europe, 90%, but 10% are not. So we always organize an event at, it's more networking events at OFC in San Diego in March, at Photonics West in January, and I'll be going to the IEEE Photonics session in Florida in November. So when you see some of our events, the participants tend to be 90% industrial. So you don't necessarily interact with Epic as the association, you interact with our members. So we provide platforms for our members to engage. In fact, I have an amazing event coming up in April next year, which is going to be 300 people, and it's going to be mainly industrial CEOs. And so I would welcome one participant from Brazil, because our events is one per company. Not two, one per company, English speaking. And if you have somebody from Brazil that would like to experience that and to bring back the experience with your organization, again, I don't know if you're all from the same university, but you find one guy and you send him and he has to report back, I would be very happy to welcome one of your participants to Europe. So on our website, you will see the events part, upcoming events, and try it out to engage with one of our events and meet industry people.
Oh, thank you very much. Thank you very much. I guess this is a great opportunity. So let's thank again.
Thank you.
So going forward for the last talk this morning, again, I'll try my best here. Dr. C.V. Pulikapsky. I'm not sure if I will ask him to say his name afterwards, that we all learn. Well, C.V. is the co-founder and CTO of Baraglia, where he invented a spectrum scan library and built a company that produces a high performance sensor with exceptional reliability and next generation of features displayed in difficult environments and is ultra secure. The technical team at Baraglia has delivered incredible advances, including the ability to measure instantaneous Doppler velocity on a silicon photonic platform. His background in developing optical sensing technology stems from the R&D role in Finisar, Australia, where he led technical teams to investigate new technologies, leading in the commercialization of instrumentations used by industrial and academic research laboratories. CV brings more than 20 20 years of experience in optics, in photonic, from developing electronic and waveguide devices to modeling a noise behavior of microwave photonic systems. So thank you very much, Cindy, for being with us, and I hope you are able to see us here and you can give this wonderful talk that we'll be expecting. Thank you very much.
Great, thank you very much for the introduction. Can you hear me all right?
Yes. Yes.
Great. Before I start, I'd love to see a show of hands how many students we have in the group.
Great.
Yeah, maybe about 30%. Okay, great. Well, when Daniel asked me to make this presentation, I was lucky because I've actually just recently given a talk on how to start a company based on university research. So I hope this is a topic that will be well received. And I hope out of this, some students feel like they have the ability to go and start their own photonic startup. Okay, let me start my presentation here. Okay, can you see my slides?
Yes.
Okay, great. Okay, so the previous two presenters talked about photonics and the impact that we have in photonics. I wanted to give you some tactical advice on how to start a photonics business. So I started this company in 2015. It's called Baraja. It's a Spanish word which means deck of cards, which I guess is not a surprise to you. I'm the co-founder and CTO with my business partner, Federico Colarte, who is the CEO. And what I thought I'd do instead of just jumping into the topic is to give you a sense of what it's like to pitch to investors or to customers. I'm going to give you a 5-minute, 5-slide pitch, which is something I have done hundreds of times. So I usually start with an image like this. This is a point cloud from our laser scanner. It's called LiDAR. It's for self-driving vehicles. And this is a aggregated point cloud of a vehicle driving down Lombard Street in San Francisco, which is a very famous steep street in San Francisco. When we introduce the company, we say Baraja is the laser eyes for driverless cars. So why did we do this? Or what's the pull from industry? Well, for autonomous vehicles, it's a very clear story about safety. In the US, almost 40,000 people die every year. 94% of those crashes cumulatively are human error. People are drunk or incapacitated. Distraction is a big one. Failure to operate their vehicle correctly. So right away, you would say, if we can make an autonomous vehicle, it's never drunk. It's always paying attention. Therefore, a big chunk of these crashes can be eliminated simply by automating a vehicle. Now, key to that vehicle, obviously, is it needs a sensor which can sense the environment, and that's what LiDAR is. LiDAR is light detection and ranging. And at Baraja, we have our own flavor of LiDAR, which we call spectrum scan, and it has a very simple premise. So if you imagine a glass prism, this will take white light and open it into all the colors in the rainbow. This is the same as saying if I put single colors in, we will obviously steer the beam through dispersion. But then you can see by changing the color quickly, we're able to steer a beam with no moving parts. And we don't use the visible spectrum of wavelengths. We use the C-band, the telecom wavelengths. But the idea is the same. We have a laser that's going to rapidly change infrared wavelengths. And thus we have a scan mechanism with no moving parts. Putting it on a vehicle that allows us to scan the environment with reliability, long life, and high performance. And so that's what we've started Baraja to be a part of. Here's what the actual sensor data looks like. This is taken on a road in Australia, and you can see that what you get is a rich 3D view of the environment, where you can tell clearly pedestrian, road, trees. And what we're demonstrating is our ability to move the scan region without any moving parts. So you can focus the attention of the laser sensor where the customer needs to see. Now, what is this market really about? Well, everyone will talk about how massive the LiDAR market is. And sure, the prediction is in 2030, it's about $30 billion of addressable market. So that's a huge market. But there are so many LiDAR suppliers out there. And when I made this slide, there were around 80. That number has definitely gone down now with lots of consolidation in the market. But what we've done for our strategy is said, well, we want to be in the high performance space, which is there's only maybe 3 other competitors in that space, and it's a smaller market, but it's about $6 billion. So when we explain to investors what we are going for, we say that it's in 2030 a $6 billion addressable market, but still growing year on year. And we've carefully designed the optics to be incredibly accurate and precise. And so when we do things like this is the Golden Gate Bridge in San Francisco, we have really detailed, very accurate scans of these kinds of infrastructure where you can see the wires along the bridge, the light posts. And that's why we believe our sensor is superior to what other people are providing. We say we move light so you can move mountains. Okay, so that was just a very quick introduction to my company and the one that I started. And I hope I gave you a taste for what it's like to pitch to external people. And you can see maybe when I give that talk, I've given it so many times, I can actually do it the minute I get up in an elevator, when I'm out for a jog, anywhere. And as a future entrepreneur, that is a skill you will also have to develop. Okay, so I'm going to talk about 4 things, and this is going to be very tactical. So I'm going to go into a reasonable amount of detail, and I hope it's interesting. It might be scary, but I hope it'll pique your appetite for some details about what starting a business is like. So the first thing is I'd like to start with a bit of inspiration, which is why risk it? It's obviously a bit of a crazy thing to start your own business and start out of nothing. So why would we do it? And then I'm going to talk about, well, what's the goal of the business and what's the team that gets to that goal? And then finally, if you really think of those in the context of getting investment dollars to be able to fund this business, you're going to realize that you very quickly need a new plan. Okay, so why risk it? Well, I thought all about these things when I started the company, which for me, I just thought, I don't know anything about this. Business is for business people. My mom said I should just get a job. And of course, she thought it was too risky. I shouldn't do it. But I think the reality is, those of us that are in photonics and working in university, well, science is hard too. It just seems like it's less risky, but actually it's hard problems. We don't know what the outcomes are going to be. Funding is very volatile, and all of us are trying to have the biggest impact possible. So in that respect, you and I, we want the same thing. We want impact. Now, what's interesting about impact is, well, you and venture capitalists want the same thing. So they want you to have the biggest impact. Why? Well, the way the math works about investors is they invest in a whole bunch of companies. And if you take a look at this slide is from one of the bigger investors in Silicon Valley called Andreessen Horowitz. And they show that 6% of their deals provide the majority of returns, and half of the companies lose money. So if you think that through, VCs invest in you to have the biggest impact possible, and then they'll get the biggest return from that. So a rule of thumb is, make a company that's going to be worth $1 billion, which until very recently meant, can you get to 100 million in revenue? Okay, so that's the premise. Let's say that happens, right? So you make a company, you're in Brazil, you're starting a company, you get investment, and it grows, and you grow to have $100 million in revenue. It's an incredible feat. Let's talk about the impact of that in terms of dollars. So, you start your new company. Now, a really common thing in Australia is that you let somebody else run the company. So you, as a researcher, say, well, this is too hard. I'm not a business person. So you bring on a professional CEO. And, well, maybe the thing that they'll do is they'll move it to the US. That has happened to many companies in Australia. Maybe it happens in Brazil as well. So then what happens is, well, look, you can grow a team of 300 in the US, and maybe in Brazil you leave an R&D team or a sales team. And that team then makes 100 million of revenue. How much of that stays in Brazil? Well, it's the salaries and expenses of 20 people, call it $4 million. So out of 100 million, 4 million stayed in Brazil. Another thing that's very common is you just take the technology and you license it. So you say, well, we don't know anything about making, we want to do the research. So we'll find a big company and we'll license it. And that happens to a lot of the Australian technology. And then same thing, well, the engineering operations, manufacturing will happen in Europe or the US. And same thing, 300 people in the US, 20 in Brazil. Well, this time you might get a little more money because you get revenue in terms of licensing fees. So you might get, now you're bumping up from 5 to 10 million. So you might think that's a good outcome. Now, what's the impact if you found that company? So you start that company and you build the company, and it's hard. And every year is really hard. And you have to stretch yourself. You have to learn how to run a company. But what happens is this starts to attract other people. And there's like a gravity to it. The company starts scaling, and you have engineers that are looking for deep tech jobs. They'll come to the company. They probably went into engineering because they wanted to do something really hard and really exciting, and they'll leave their jobs to come work for you. Similarly, grads that would have had to have moved to the US or to Europe to find jobs in photonics, now they find the job of their dreams where you are in Brazil. And then you flip the math there. Maybe now you have 250 staff in Brazil and 50 overseas. That means out of the 100 million, you're getting the salaries and expenses of all that staff, plus 30% margin on that revenue, call it $80 million. And $80 million that now you're in charge of, and you get to decide where that goes, into hiring people, into investing locally. That's the impact. So we're talking about technology to improve something, meaningful jobs with purpose, profits that come into Brazil to be invested, and replicating this, inspiring the next generation. Okay, so let's take that as given. You are inspired, you want to have that impact, that's what you want to do. You want to start this company. So what's the goal? And the funny thing is that technology and products are not the same thing. So we have photonics, and photonics is everywhere. Carlos gave a great overview of how many varied things you can be involved in photonics. And here's three particularly big things, which is LiDAR and sensing in photonics. You get a lot of integrated photonics in this. There's a lot of quantum photonics out there, and of course interconnects are a huge thing. So in a way, it's really simple. And this is a quote from a notable blogger, investor in Silicon Valley called Elad Gil. And he boils it down to three things. Founders need to do three things. From the bottom, don't run out of money, which is obvious. Resolve co-founder conflicts, which is very common and much deadlier to startups than you'd think. And number one is find the product market fit. So product market fit is you make a product and there's a market there that wants it and they fit together. Now, when I talk to people coming out of universities, I often worry, or I've seen, that they want to build something like this, which is a company full of scientists. So, maybe grab a bunch of scientists from a research group and then hire postdocs and PhDs and grads and give people titles and roles that they're not experienced in and say, okay, now this is the company. So that's not a great way to start a company. And I'll go through maybe what a team could look like. How do you figure out what to make? So this part is a hard thing too, because now you've, in this startup world, a lot of people building things have no technical risk, particularly software companies. They generally just have to make a product that fits, and the technology is something that exists already. In photonics, we are in this quadrant here, deep tech. There's R&D risk, there's product market risk. It takes a lot of capital and a lot of effort. So this is the hardest thing you could be doing. But if you're like me, that's all you want to do. I wouldn't want to do anything else. So then the job you need to do. What is the goal? You need to get this far. Meaningful de-risking of the technology. So you're building photonics, so you got to make as much progress on de-risking it, and then getting to a minimum viable commercial milestone. What are commercial milestones? Here's an example of some, and from worst to best. So the best thing you can get is a supply agreement, which is some company gives you a contract to buy a certain number of your products for a certain number of years. After that is a purchase order for just one batch of units. Below that, I think, is a paid trial, which is a pretty common outcome where you convince a company to give you money in exchange for trying your product. Further down the list is an early access agreement, which is if you have something that's really unique, and photonics does fall into this category. If it's doing something people cannot do with another technology, they may pay you just to be part of the development cycle. And then last is what we call the memorandum of understanding or letter of intent, which is just a letter from a company saying that they would agree to work with you. All of these are things that you would need to do to be able to raise money from investors. Most deep tech startups start here. In my company, we were able to get money from pretty big companies for this. Obviously, going up to purchase order is something that would be amazing. Purchase orders for products. So that's the job to do. You got to find a customer at any level that's going to pay you. And that's one of the most challenging things, because getting to something that you can sell is already a challenge. But now trying to match that to a buyer, that's an enormous effort. And that's part of the special magic that you need to bring into the startup. Okay, so we talked about the goal, which is product market fit, not running out of money, finding that magic and getting someone to buy what you're making. Now, what's the team? So you need a team that's going to execute on those goals. And I shared earlier that org chart of a company that's going to fail. So let me be really directive, and take it as you will. But this is an example of how you would do early stage organizational design. So number one thing is you're running the company, but hire people much better than you. Take your ego out of it. Understand that they're helping you to build your vision. You got to keep the organization flat, because everybody has to go in the same direction. So from the product point of view, here's an example. We got some photonic magic in black. This is a chip that you're making or an idea that you've had. You've got this bit of photonics in here. That's the special bit of science. Now, for that to interact with the rest of the world, generally speaking, you're going to need some electronics, some mechanics, some firmware and software to interface to the customer. Right? Every product needs to have some of these, unless you're in the rare camp where you have something that's a purely passive photonic product. In this case, here's a template for 10 people. And this is, how I built my company to begin with, and it works fairly well, which is you have one of the founders be the CEO. You have the next founder be the CTO, and you try to split between business and science. And then you hire a really great engineering lead. And they exist out there, they're managed 20, 30 people. And that engineering lead has to be really capable of doing product cycles. And they're going to go and hire for you an electrical engineer, a firmware engineer, software engineer, a mechanical engineer. And then on the photonics side, then, for example, you hire 2 experts in photonics to help get this thing working. And then you get 1 person to handle the operation. So that's 10 people. That's a fully formed company that can deliver on a product. And maybe I won't go too much into this, but as an aside, whatever you pick for the compute platform is going to massively impact how many people you need. So, for example, my product uses this, a Xilinx FPGA. And so we have, between this and we've had much bigger teams than this, but you will have tons of people to have that. If you can keep it down to using a microcontroller, then you can get away with a much smaller team. And that's a lot cheaper and a lot faster to iterate. On the photonics side, so a great thing for early stage startups are the multi-project wafers. It's probably something you've heard of. IMEC has it, HHI. And what this does is you can do an integrated photonic chip with just a few dies on a wafer. It's a fraction of the cost of doing the whole wafer. It comes with its own problems, which is it has its own timeline. And my personal experience is wafer runs can have serious delays. So for me, unusable in a startup. Okay, so we talked about the goal, which is getting the product market fit. And then we came up with a generic team that can execute on that. So what is the plan that you need to put together to talk to investors? So deep tech means that you're not going to get to break even very soon. You're going to have to get to the next stage of funding, and that becomes really key for photonics companies. So here's an example. I put together an 18-month plan. Month 1, you have cash in the bank from your first round. Month 18, you're out of money. Or you need to have cash in the bank from your next funding round. So I put here 3 months to hire the team. What's the rest of this? Well, the first consideration is, if we work backwards, is it takes between 3 and 6 months to close a round of funding. So from wherever it ends, you need to budget that there's going to be 6 months before this. And if you're crossing whatever holidays your investors are in, they're usually not there. So between December and January in Western countries, typically no deals get done. It can happen, but generally in the US, you want to wrap up any deals before November, or you have to start again in February. Now, to make this really successful, to get investors excited, you want to have commercial milestones. So you need to have one to kick off the fundraise. But if during your fundraise procedure, if you have other commercial milestones drop, this will get investors excited. It might get more investors to the table. You might get some competition, and this will make your fundraising experience much, much easier. On the other side, I mentioned the concept of hiring an engineering lead. This is the most important hire. And for this plan to be successful, really, you need to have that person from day one. So this is someone that you should, if you are starting a startup and you're about to raise money, you should have that person in the pocket. And you leverage them to hire the engineering team. Why? Because if you're an academic or you're a young student, you don't know what makes these engineers excellent. So you need to rely on someone that can hire excellent people for you. That's key. Okay, so then a perfect plan would look like this, that you hire that engineering lead. The rest of the team comes in the next 3 months. And then within 6 months, you are getting your electronics, firmware, mechanical designs done. Photonics drops in month 6. You have parts on hand, and then you have 3 months of integration and test, which is often the most painful, but often the most rewarding part of a cycle. And that's wrapping up so that you are doing demos, you're doing tests, you're doing validation with a customer, so you can sign some early commercial milestone, like a letter of intent. And if that follows, then you do 3 of those and you're fundraising and you get money in the bank at month 18. So that's a perfect plan. So that doesn't really happen. So this is more like what happened to me, which is we got cash in the bank and we didn't have an engineering lead. And we were new entrepreneurs, so we didn't know how fast we had to hire. So we took our time. We wasted a lot of time hiring the team. And then by the time we got to design and integration and test, well, we got to the end of the year, but we were pretty happy. Okay, we got parts on hand. Let's test it. Nothing worked. And we quickly panicked. We did a redesign, and we did testing, shipped, design, test, ship, cycle after cycle in very quick intervals. Very intense part of my life. But then we were able to get something that worked and able then to pull in more money into the company to keep on going. So that's an example of having a great plan and having an actual execution that doesn't match that. So how do you avoid a lot of that? Well, the stronger the eng lead is, the less chaos will occur. The tech risk is difficult to plan for. So what I would advise is do the least amount of progress on tech risk for your product. I mean, you still have to de-risk it overall for the business, but for your timelines, you try to not take on as much technical risk because it will delay you. And then the last thing is on the team that executes. Startups don't have time for people to learn slowly. So if they don't fit, then you have to fire and change people in the team. Okay, so just to summarize, so I gave you a very deliberate plan for how you can start a startup, get to product market fit, have a team of about 10 people. With 18 months of funding, you'll have to raise about $3 million USD. Now, the great thing is in Brazil, I understand that salaries are a lot lower, so you can start a startup and get going with much less than this. And with that, remember, all you need to do is get to your next milestone. Next commercial milestones will get to your next funding round. All right, so with that, I'd like to say, again, we move light so you can move mountains.
H-side. Okay, questions? Comments? Maybe, pode ser em português? No, stop.
Thanks, Phoebe, for your great insight on startups and also on the particular topic that Baraja is working on. And I'd like to add a question on that. So I've been recently talking to people and I've heard, which I don't understand fully, that the LiDAR market is sort of depressed at the moment and not being in the field. And I mean, as a photonics enthusiast, I always like to quote LiDAR as one of the most amazing applications of integrated photonics, recent laser developments, and etc. So I must say I was a bit in shock that that there's, despite all the applications as you pointed out, this has been stuck somehow. Could you comment on that a little bit, if that's the case or not?
Sure. Well, you are correct. It is very depressed. Now, what are the reasons? Well, it's, I think, typical technology cycles. So LiDAR is a incredibly useful sensor for all robotics, and it's necessary. So I think you will see the growth, and we have seen the growth of LiDAR sales globally in all areas. Now, all the LiDAR companies, myself included, we have been targeting automotive. And as you can see from the news, robo-taxis have had quite a slow deployment. People claim they were going to be driving us around in 2021. That's far from where they are now. And where we are seeing growth is car manufacturers slowly adding LiDAR to some models of vehicle. And in China, you see many more. What that means is all the revenue expectations for all these LiDAR companies is far below what they promised. So as a result, in the public markets, LiDAR companies have lost, I don't know, between 60 to 90% of their public market value. So that's causing the depression. That's just the timeline to those revenues is far delayed.
Any other question? I guess I have one. I enjoyed pretty much seeing the question about the way you describe that actually doing science is probably as risky as becoming a programmer. Although most of our students, grad students, they expect to become a professor, right? That's the case in English. So I'd like to know in Australia if this is the same thing and what you're doing to really change this mindset for them to believe and try to actually make an impact and actually inspire the next generation, such that I tell them that you probably be hiring people that you're the next generation of students. So what are you doing there in Australia to change this mindset?
So I do a lot of this. So I speak at a lot of universities on the topic. We also have a couple of investors that run programs for academics or PhD graduates that are interested in starting a company. They can go through some startup-like activities to see if their idea has, some potential market, and they pair with mentors. So I spend some time doing that as well as running my business. I think it's really important, and I like to think that if you can advise PhD students that want to start a business early, then they have maybe a greater chance of success given the right steerage.
Last question. You have a question.
And I would like to ask that I work with LiDAR for geology, and I see like a problem that is most of people who work with geology and I believe other science really don't know how to use LiDAR data, sensors, and some stuff like that, and it's a little expensive as well. So, do you think that there's a solution for it, for people to get more into LiDAR and try to work with this data, because it's a little bit heavy, it's a little bit different from other sensors?
Yeah, that's an interesting question. So, I think LiDAR is a difficult sensor to work with because of the quantity of data and the nature of the data. So it produces a point cloud. So now if you want to work with it, you have to all of a sudden be an expert in 3D space. It makes it challenging. Now, what's the great thing about the academic industry is there's a proliferation of open source libraries, like especially if you're using Python. There's a lot of tools that you can download, a lot of repos that you can clone to accelerate a lot of this learning. So you can do things that will make a lot of your life a lot easier. Now, the other thing is, I think what we'll see over time is you'll start to see more and more LiDAR sensors coming with perception, what we call in the box, so that customers, the customers that don't want to deal with 3D point clouds, but just want what's the object in front of me. I think that's something that you'll start to see more and more of, especially as the artificial intelligence gets shrunk down and it can run on embedded hardware. So that's where I think the future goes.
Oh, let's thank Stevie again and all these speakers.
Thanks, everyone.
I guess it's coffee break now, right? As far as, am I correct? Yes. Gente, tem cafezinho. Lembra que vai aparecer uma palavra em algum lugar aí que vocês poderiam entrar na competição para o AirPods. Eu não sei que hora que apareceu essa palavra. Tem que pedir para o ajuda aos universitários. Okay, so coffee break. Let's try to come back. Maximum like 10:35, because then we have to recover a little bit. Tentar voltar tipo 10:35 para a gente não atrasar muito, tá bom? Mas eu sei que é difícil. Obrigado.
Eu te mandei, eu fiz quando faria baseado na lei, tá lá. Eu não gosto de falar mais de baseado na lei. Fala.